This video explains EOQ model. EOQ stands for economic order quantity. So to use economic order quantity model, we have some basic assumption EOQ model. So EOQ stands for economic order quantity. So we want to find the economic order quantity based on some assumption. So actually, economic order quantity model, EOQ model, is very fundamental and traditional, has the longest inventory model. So also, but this EOQ model has some unrealistic assumption. But basically, this model can provide very good insight for our inventory model. First of all, we have this kind of notation. We have annual demand. This is constant. This is actually constant. Means there is no uncertainty. We have a certain demand. Also, we have fixed lead time, but for fixed lead time, we don't need to take into account those fixed lead time because we have to place order before a certain date. And also we have purchase cost, the price of product, and holding cost. Typically we use inventory holding cost for opportunity cost or inventory manager, or we need some insurance or utility expense. Also we some monies are tied up with inventory, so that's why we use holding cost. Typically, holding cost is kind of some percentage of purchase cost typically. Then we can compute this percentage of purchase cost into dollar amount, and we finally you have to compute the dollar amount, and we have a setup cost, so individual setup cost. Then out of this, we have to determine all these numbers are given, and out of this we have to compute the quantity. This is our decision variable. So means we have to decide this order quantity. This is actually order quantity. Out of this, we can compute the total annual cost. Total cost is equal to annual purchase cost plus we have to compute annual setup cost. Also, we have to compute annual holding cost. And to compute all these numbers, basically we have to know the basic inventory profile. So here is inventory profile, and we order queue, and the customer comes, and if we have lead time, and then there will be some reorder point. ROP is reorder point, and this is actually lead time. But after this lead time, supplier will deliver exact quantity queue, and then they repeat the same cycle, and also inventory levels goes down up to ROP, and we order again, we place order, and it takes lead time L, and then we have another inventory, and we receive another inventory order Q, and we sell this product. So this D is demand rate, and also we have time period T, and we have a quantity Q. Then we have this kind of equation. D is equal to T over Q. What does this mean? So actually this mean is D is constant slope. This is a consumption rate. So this is based on time T, each cycle time T, also each order's quantity Q. So we have this information. And also annual purchasing cost for annual purchase. What is total purchasing amount? Total purchasing amount is D, and times unit cost. This is annual purchase cost. And what is annual setup cost? how many setup do you have? Actually, we have total demand D and divided by Q, that is number of setup, and we multiply S plus that is the setup cost. And finally, annual holding cost. What is the average inventory? Average inventory level, so total level, maximum level is Q, minimum level is 0. So what is the average of this? And 2 over Q is average, right? So actually this Q, this is half of Q is our average inventory level, and the holding cost H. So out of this is always same constant. So we do not take into account this DC, but we will take into account only setup cost and holding cost, only these two. So we build up this inventory model. I mean, we compute the total cost, right? So based on this total cost, so we want to get economy order quantity. So basically, we have to draw this function. This function is total cost function is function of Q. So now we try to compute this one. So total cost C is a function of Q is actually D over Q times S plus half of Q times H. That means now let's consider quantity Q and the total cost value. Then holding cost is linear function. This is actually linear function. This is 1 over Q function. Decreasing function, right? Then we have setup function looks like this. This is Q over function. So then we have to add these two numbers. Then if you add these two numbers, and then total function looks like this. And also this quantity is optimal quantity Q star. So if they have the same order quantity, I mean they intersect, these two curve and the line intersect a certain point. Actually this quantity Q has minimum point. When do you have minimum point? Q over ds is equal to 2 over QH. Then you can solve this algebraic equation, and then finally Q star will have this square root form, 2 times ds divided by s form. So this is our economic order quantity. Economic order quantity depends on demand, also setup cost, and holding cost. Actually, economic order quantity is proportional to setup cost, and proportional to 1 over holding cost means if you have high setup cost, then your economic order quantity will be very high. But if your holding cost is very high, economic order quantity will be smaller. So that will be intuitive, right? So we will use this kind of equation, but you don't need to draw all these equations. Basically, you have to know annual setup cost, you have to know annual holding cost. At the same time, you have to know this economic order quantity. This is our final conclusion, and we can apply this idea in Excel.